Welcome you all for the problems on Poisson distribution. Last video we discussed discrete probability distribution and restricted to only binomial distribution. In this video we are going to discuss about Poisson distribution. If P stands for the probability of success and Q stands for probability of failure, so that P plus Q equal to 1 always, then the possibility of getting X success out of n trials is given by the Poisson distribution P of x equal to m power x e power minus m by x factorial. Here m will be equal to mu, and in this particular case, in the case of Poisson distribution, V is also equal to mu. Okay, mean and variance are equal in the case of Poisson distribution, whereas in general for any binomial, for any discrete probability distribution, mean is given by np. Keeping that in mind, let us move on to problems on Poisson distribution. These are the things we need to keep in mind. P of x equal to m power x into e power minus m divided by x factorial. Now, the first problem I am going to consider is the number of accidents per day, that is recorded by some institute is, okay, the number of accidents per day recorded by an institution for 400 days is given in the table. Number of accidents per day for 400 days is given in the table. We have to fit a Poisson distribution for the data. We have to fit a Poisson distribution for the data and find theoretical frequencies. We have to find theoretical frequencies. So practical data is given. We have to determine theoretical values. So the data is x, that is accidents, f, frequency of accident. So 0 accidents 173 days, and 1 accident 168 days, 2 accidents 37 days, 3 accidents 18 days, 4 accidents 3 days, 5 accidents 1 day. Okay, now we have to compute these values using Poisson distribution. Theoretically we need to compute that values. Now by Poisson distribution, we have P of x equal to m power x into e power minus m by x factorial. First we need to determine m. What is m? M equal to mu. That means we need to compute number of accidents per day. We have to compute number frequency of accident per day, we need to compute. So mu will be equal to total number of accidents f into x. Not it is not f of x, it is f into x divided by summation f, total number of days. It is actually 400. So 173 accidents for 0 days. So it is 173 into 0 plus 168 into 1. Oh, sorry, 0 accidents for 173 days. Sorry, I said it in opposite way. 2 accidents for 37 days. So 2 into 37 plus 4 into 3. Okay, forget one more thing. So 3 into 18 plus 3 into 4 plus 1 into 5, all divided by total frequency, that is 400. So this will give you 0.785. So on the average there are 0.785 accidents per day. There are 0.7825 accidents per day. Now let m equal to mu equal to 0.7825, then p of x will be 0.7825 whole power x into e power minus 0.7825 divided by x factorial. We can compute this value e power minus 0.7825. So by computing that, we'll get, so p of x equal to, I'll write here only. It will be actually, okay, that I'll compute later. Okay, this is for p of x. This is Poisson distribution that is fit to 1 day. Poisson distribution that is fitted to 1 day. We need the data for 400 days. So we'll do one thing. Let f of x equal to 400 into p of x. Then it will be 400 into 0.7825 whole power x into e power minus 0.7825 divided by x factorial. Now simplifying this, we'll get f of x equal to 182.9 into 0.7825 whole power x divided by x factorial. Okay, now we need theoretical frequency. Actual data we need, actual data we have already. We need theoretical frequency right now. Now f of 0 equal to, so earlier we had 173. Here you can check that it will be 182.9 into 1. It is approximately 183. Then f of 1, earlier we had 168. Now computing here, we will get 182.9 into 0.7825, which is approximately 143. Then similarly, f of 2, it will be approximately 56. Similarly, you can compute all the values. F of 3, on the average it is approximately 15. F of 4, that is approximately 3, and f of 5, we get approximately 0. So these are the theoretical frequencies. Now next problem, the number of accidents in a year. Problem number 2, the number of accidents in a year for a taxi driver follows Poisson distribution with mean 3. Out of 1000 taxi drivers, find approximately the number of drivers with no accidents and second one, more than 3 accidents. Okay, solution. Given mu is 3, the mean is given as 3, so we have m equal to 3, and hence p of x will be e power minus 3 into m power x, that is e power minus 3 into 3 power x, into 3 power x divided by x factorial. This is the Poisson distribution that is fixed to one taxi driver. I need the probability for 1000 taxi drivers, so it should be multiplied by 1000. So f of x equal to 1000 into P of x. So it will be 1000 into 3 power x into e power minus 3 by x factorial. On simplification, it will be 50 into 3 power x by x factorial, because e power minus 3 is approximately 0.05. Now first case, no accident, that is possibility of x 0, that is 50 into 3 power 0 by 0 factorial, sorry, you can check that it will be 50. Next, more than 3 accidents, that is we have to find p of x greater than 3, which will be obviously 1 minus p of x less than or equal to 3. So it is 1 minus p of 0 plus p of 1 plus p of 2 plus p of 3. You can check that this value will be equal to 0.35. So this is p of x greater than 3. We need f of x greater than 3, that is actually 1000 into this, so it will be 350. 1000 into 0.35, it will be 350. So that will be the required solution. So let us consider the last problem. The last problem is 2% of the fuses manufactured by a firm are found to be defective. So 2% fuses are defective. So here P will be 2%, that is 2 by 100. Find the probability that a box containing 200 fuses contains no defectives. Second one, 3 or more defectives. Solution. So here P is 2 by 100 and it is stated that 2% of the fuses manufactured by a firm are found to be defective. Okay, then each box is containing 200 fuses. So the mean number of defectives is mu equal to total number of pieces into the possibility of each piece being defective is P. So N into P, it is actually 200 into 2 by 100. So it is 4. So we get mu equal to m equal to 4. And hence P of x will be 4 power x into e power minus 4 by x factorial. That is approximately P of x equal to 0.0183 into 4 power x divided by x factorial. Now the first case, probability of no defective fuse, that is P of 0. Since we are doing this calculation for a single box, no need to multiply this P by any number. So P of 0, that will be, you can check that 0.183. And the second one, probability of 3 or more defective fuses. So it is P of x greater than or equal to 3, that is 1 minus P of x strictly less than 3. You can check that it will be approximately 0.7621. So this completes the solution of the given problem. With this, the discussion on Poisson distribution is over.